Factoring completely is kind of pulling everything together from 7.4 onwards. So chapter 7 wrap up. Originally this was part of lesson 7.8, but we started 7.8 with the factoring by grouping. So keep the flow chart handy during the 3 or 4 examples I do in this video, just so you can follow which step I'm on. First example, we're going to look at our flow chart and see what to do. So we're going to start with step 0. Step 0 says if your problem is an equation, get every term on one side so it equals 0. Well, mine currently does not do that. So I need to subtract 10x on both sides. I'm going to keep it in standard form. So the x's go from biggest to smallest, x cubed, x squared, just plain old x. And now it equals 0. So that was step 0. Step 1 is to factor out the greatest common factor if there is one. So let's see if we can factor anything out of this. They are all even numbers, so they should all be divisible by 2. 2 can't be divided by anything bigger than 2, so that must be the biggest. And then I have 3x's, 2x's, 1x. I can take out 1x. Then the 10 runs out, so I can only take out the 1. And I'm left with 2x. 2 divided by 2 is 1. X cubed over x. X squared is left. Plus 8 divided by 2 is 4. X squared over x. 1x is left. Negative 10 divided by 2 is negative 5. X over x, no more x's. Okay, so this is where I'm left after step 1. That was factoring out a GCF. Now this is where my flowchart splits. Am I left with 4 terms or a quadratic? So what I look at is this inner part here. This is a quadratic because it has an x squared, and it's only 3 terms, so definitely not 4 terms. We'll have to remember this 2x's over here when we get to the end of the problem because it'll be part of our solution. So now I do my normal factoring process. So a times c, 1 times negative 5, I'm factoring negative 5. All right, so this is the factoring steps. I could list out all the separate steps, but the flowchart is a little different than using the box like we did in class. So when I factor negative 5, I really only have one option, negative 1 and positive 5. There are no other factors. I just need to make sure the 1 is the negative thing, because remember, my goal is to get this 4 in the middle, positive 4. So I'm going to draw out my box now, fill in the corners. I got negative 1x and 5x. And then from my original, it was x squared and negative 5 down here. X squared is easy to factor. These just both have to be x. And then x times negative 1 is negative 1x. X times 5 is 5x. Negative 1 times 5 is negative 5, so that checks out. So I'm going to rewrite this with all 3 factors, these 2 and the 2x from before. All right, so let's look back at our flow chart. So rewriting is the final step. All right, rewrite the quadratics. So here we're going to have 2x from what we originally factored out, x minus 1, and then x plus 5, and we equal 0. All right. So this lines up pretty well with the example on the front page of the notes inside. So I guess the back of the front page. So now my solutions come from the zero product property. So let me do that over here so I'm not in the glary spot on my whiteboard. I have 2x equals 0, x minus 1 equals 0, and x plus 5 equals 0. I think we can mostly mental math this, but I'm just writing it out so you know that this is really what the zero product property looks like. Divide by 2 on both sides, add 1 on both sides, subtract 5 on both sides. These are each just one step at this point. X equals 0, x equals 1, and x equals -5. This is our final answer. All right? We had 3 solutions for this problem because we had 3 factors when we got to the end with the zero product property. So, factoring by grouping. We get it to equal 0. That's step 0. Step 1 is to factor out a greatest common factor. We may not always have to do these 2, but you got to think about them. Then, since we had a quadratic left, we factored with our normal quadratic factoring skills, and then the zero product property at the end. So if we go through the lessons, getting it to equal 0 is just some of our background knowledge. That's just algebra skills. Factoring out the greatest common factor is from lesson 7.4. This factoring process is all of the 7.5, 7.6, and 7.7 lessons. They're all really the same. 7.6 is where I did the first examples, but there's examples in all of the videos. And then the zero product property is back to 7.4. Okay? And this whole process is called factoring completely. So let's look at one more that doesn't make us do the quadratic thing, but instead makes us do factor by grouping. Let's start with step 0, making sure that it equals 0 over here. So I'm going to have to subtract both of these things, minus 4x and minus 4. Reminder, let's try and keep it in standard form. So x cubed is the most x's, then x squared, then -4x, and then minus 4. Right? X cubed, x squared, x, no x's. And since we subtracted everything off the other side, it equals 0. That is step 0. Now, we try to factor out a greatest common factor. Not all of these have numbers in front of them, so I can't really factor anything out of a 1 besides a 1, but there's no reason to do that. And they don't even all have x's. So I'm going to say no GCF. So skip step 1. All right, and now this one is 4 terms, which means we're going to move on to factoring by grouping. So this is step 2 in the factor by grouping section. By grouping. So if you need a refresher on this, this is from lesson 7.8. which is what we started before we started really factoring quadratics. So factoring by grouping looks like grouping your first 2 and your last 2 terms, factoring stuff out. So this first pair, there's no numbers to factor out, but this has 3 x's and this has 2. I can take out 2 x's before I would run out. Then these don't have enough x's to factor any out, but they both have a -4, so I'm going to factor out -4. Now what do I look like? X squared, and then my leftovers. X cubed over x squared is 1x left, plus x squared over x squared is 1. Anything divided by itself. Then we do plus -4. -4 over -4 is 1 with an x. And then -4 over -4 is just a 1. And look, our parentheses match, which they're supposed to. So I'm going to factor out the parentheses. And at this point, I'm going to shimmy my problem back up here to get out of the glare again. So now I have x plus 1, and then my leftovers, which are the things in front that we factored out in the factor by grouping step. X squared minus 4. Now this, let me make sure that looks like a 2. This is difference of squares from lesson 7.7. So I am just going to use that pattern to figure this out. The square root of 4 is 2. So I'm going to get my x plus 1 that was already there. And this, x squared minus 4, becomes x plus 2, x minus 2. And this whole factored form equals 0 because our original problem was an equation to solve. So remember, we got it to equal 0. So let's mental math this one. This would need to be a -1. This would need to be a -2. And this would need to be a +2. Remember, we're trying to get each of these to equal 0. So x is -1, -2, and +2. So another problem with 3 solutions. All right, so this is called factoring completely once again. So if you need to review things, 7.8 walked through factoring by grouping. 7.7 is how I knew this was going to be x plus 2, x minus 2. Pulling a lot of ideas together. There's a lot more to practice on this note packet, so if you need extra practice, do some of those and compare to the answer key that I'll have uploaded.